Okay, so I am now on page 21. Okay, so page 20, these were the notes that we finished off with the last video. And now we're going to look at some algebra tricks with special trig limits. I call them tricks. They're not tricks, they're algebra, but it's really kind of maybe thinking about things in a different way than you have before. So one of the things that we want to know about this, so we just had a theta and a theta. So I just put two empty boxes here to say, as long as you have the same thing in those boxes, that is equal to 1. You don't have to prove it. That's something that we can say. As long as those are the same, it's equal to 1. Okay, so let's look at this problem right here. So I'm thinking, well, the limit as theta approaches 0 of the sine of 5x. Well, lo and behold, those are the same exact thing, so that is equal to 1. Okay, so that we don't have to prove anything. We're not going to plug that 0 in. It's a special trig limit that we're allowed to just say, I know that that's 1. Okay, well, we've got to bump it up a little bit, right? So let's look at the limit as theta approaches 0 of the sine of 5x over 10x. Okay, so I want it to look like that, so I can say that these are going to cancel out. So here's what I'm going to do. I'm going to rewrite it. And when I rewrite it, I'm going to keep this limit notation on there. So what if I said, this is the sine of 5x over 5x times 2, right? Because 5x times 2 would give me that 10x back again. Now, I can't just go, oh, well, I know that that's a 1. We have to split this apart. So remember that we said you don't have to do direct substitution here and show that it works. You have, because it won't, because of the, it'll be the indeterminate form. But we are allowed, if we can show this one little part, we're allowed to do that. So here's what I'm going to do. I'm going to break this up, and I'm going to say, this is the limit as theta approaches 0 of the sine of 5x over 5x times the limit, and we had a rule that said we could do this, of 1/2, right? Because if I take that 2 right there out, so if I did this times that, I get this back again. Okay, well, we know that that is 1. And this is a constant. And we said if you ever have a constant there, it just equals that constant. So there it is. Okay, so I did have to kind of prove it by showing that part. Okay, so don't just go, oh, I can do that in my head. It's kind of like a no-no, not allowed. Okay, let's look at another one. Let's say we have the limit as theta approaches 0 of 3 times the sine of 5 theta over 2 theta. So one of the things you have to keep in mind is that when I'm trying to manipulate this, I can't go, oh, I'm going to make this up here a 2. You can't mess with that at all, because sine 5 theta, that's like it's a thing. It's completely together. Okay, so don't mess with any number right here. We can only mess with the number down here. So if we had a 5 theta down here, we'd be in business, right? Because then we could do our thing. Okay, so watch what I'm going to do to make that happen. So how about if I just multiply the top and the bottom by 5? I guess I didn't need a big space there. So I'll put it on, actually, let me put it on the other side. So it's really, the 5 is like there. Okay, and then I'm going to multiply the bottom by 5. So this is one of those things where you want to be really careful that you're understanding how the algebra works. Because sometimes I see students, they kind of don't have the algebra, and then they get the right answer that happens to just be like, oh, well, it's weird that it worked out that way, but that's not how you do it. And then they do a bunch of them wrong. Okay, so when I multiply this top by 5, don't think of this as the distributive property. I can't just go right into there. Sine 5 theta, I can't multiply. This gets multiplied right there. Okay, so this is the limit as theta approaches 0 of 15 sine of 5 theta. And what do you think? Could I just rewrite this like that? So 2 theta times 5, that's just 10 theta. Well, that's the same thing as 2 times 5 theta. So again, these are all little algebra things that we've known, but we've never kind of really manipulated them before. Okay, so let's get this all nice and pretty then. So we're going to have the limit as theta approaches 0. So that'll be 15 over 2. So I'm going to separate times the limit as theta approaches 0 of, oops, that should be the sine of 5 theta over 5 theta. Okay, so now we know that's a constant, so this is just 15 halves. We know that that's 1, and I'm showing that that's 1 right here. It's just one of those things like you can't just, it just goes away. So even though obviously you can do that in your head, you got to show that that's what happened to it. It turned into 1. And there's my solution. Okay. Okay, so things I want you to note is that this applies to the cosine limits as well. So as long as we have the limit and we have a box over a box, if those guys are the same, that's going to be equal. And we don't have to prove it. And if the limit as theta approaches 0 of 1 minus cosine of theta over theta, or excuse me, cosine box over box, as long as those guys are exactly the same, that will also equal 0. Okay, and what we'll do on Monday is we'll do like a bunch of practice problems together in class, so we just start to get more comfortable with these little trig limits. Yay, we're almost there. Page 22. Let's look at one more example. And basically what you're going to see is that we're practicing algebra is what we're doing. You guys don't have any trouble learning a new little rule, but applying it to something that you're not as comfortable with is what's hard. Okay, so, kind of looks like what we've seen. We've seen that if I had a 3 theta on the bottom, and we've seen that, and we have this rule that says you could add limits together. So if we could add them together, then we should be able to break it apart. So again, I want you just to note this strategy here. This right here is the same thing as 1 minus the cosine of theta over theta plus the sine of 3 theta. Oops. Right? Because they have a common denominator, so I would just add those together. So I can pull those things apart. Okay, so now I'm going to do this. Well, then this would have to be the same thing as the limit as theta approaches 0 of 1 minus the cosine of theta over theta plus the limit as theta approaches 0 of the sine of 3 theta. Okay, we're getting closer. Getting closer. What do we need down here in order for us to simplify this? Anybody? Anybody? A 3. Well, let's multiply the top and bottom by 3. Okay, so now this we know is 0. I can go ahead and simplify that part right now. Okay, so 0 plus, this is going to be the limit as theta approaches 0 of, I'm going to do this part, sine 3 theta over 3 theta times the limit as theta approaches 0 of 3. Right? Because that times that will give me that. Okay. So now I have 0 plus 1 times, there's that constant, 3. And our limit is 3. Alrighty. What do you guys think? I know what you think. I knew it. I knew it. All right, you guys. That is it for this right here. Hopefully I can turn this video off. Have a great day. Bye-bye.